everybody. I was just out on a spacewalk right outside the space lab here. And I was looking at the stars, honestly. I was looking up at the stars. People have been looking at the stars, connecting those dots for ages and making constellations. Me, though, I look at them and I see 3D geometry, right? They kind of remind me of vertices, 3D points in space. And it gave me the great idea to do something with WebGL this episode, but I don't want to go for Three.js or Babylon.js quite yet. You can create amazing looking 3D content in these libraries, but there's a steep learning curve. There's a lot to learn. Managing 3D models, I just don't want to go there yet, but I also don't want to go through the hassle of starting from scratch in WebGL, working with a bunch of WebGL boilerplate code. I really just want to focus on the shaders, avoiding the canvas setup, avoiding the WebGL context setup, all of that funky code to create programs and uniforms, managing them all. The shaders I want to create, we have the vertex shader to create the geometry and a fragment shader to control how that geometry is kind of filled in. We're going to be working with simple shapes, honestly. Honestly, like a square or a rectangle to fill in the entire viewport on your screen. Even so, it's so powerful what you can do with WebGL, shaders, and a lot of math. Lucky for us, Shader Doodle by our special guest Merle, it makes things a lot easier. We're avoiding all that perplexing setup and program creation. We're focusing on the other hard part, actually making the shaders. It is super hard, but at least we don't have all that boilerplate stuff to bog us down. So in this episode, we're going to create an application with Shader Doodle. And creating this application, it's going to be a lot like creating our halftone application in episode 1. We can treat both components, the halftone one and now Shader Doodle, like a bit of a black box. We can trust them to do all of the hard work for us, and we know that underneath there are some fairly complex things going on in each one of them, but again, they are web components. We throw a tag, a custom element on a page, and this complexity is completely hidden as we work with it, unless we want to go poking at the source code. Now, Shader Doodle, it's slightly different than the halftone one from the last episode. It doesn't have much of a JavaScript API we need to worry about, but instead, the setup is mostly a really nice and smart combination of custom element tags. So you have the outer tag, the Shader Doodle tag, and then inside, you can add some texture tags, or you can add an audio tag, or some buffer tags. It really works out nice, and you're just working with HTML markup. Anyway, in this episode, we're going to be using the same 3 main technologies as we did in the last one to build our application. We're going to be using Lit, we're going to be using WebDev Server, and we're going to be using Spectrum Web Components. So we're not going to change up the formula too much just yet, but I think it's time to recognize that they can get a little more complicated than our easy and straightforward application from last time. Now, I don't want to diminish what we did last time. Creating our halftone application, it was a pretty nice application, right? And it did take a long time because it was our first time using all of these new technologies, and we took it very slow as we explored. For Spectrum Web Components, we won't be doing anything extra above or beyond what we did in episode 1, but just to mix things up a bit, we will be switching to dark mode for our Shader Doodle application. We're also going to be using 1 or 2 new components. I can think of the accordion component off the top of my head. So anyway, nothing new with Spectrum Web Components really, but we will be switching up our front-end tooling a fair bit. With our second technology, Lit, we will be switching over to using TypeScript. Now, to be perfectly honest, I'm not so much of a fan of using a language like TypeScript that transpiles to JavaScript when we could just be using JavaScript from the get-go. We could have a much simpler front-end tooling setup. I don't like extra steps, but I just saw something that proves we need to explore TypeScript. This was a chart I just saw. It shows the most popular modern languages, and TypeScript was right up there at the top with JavaScript. So I feel like if Lit, WebDev Server, and Spectrum web components, if they weren't compatible with TypeScript, our tools that we're learning, they'd be a complete non-starter, especially for corporate environments where types can be hugely important for many devs working in these large code bases. But all that said, it's really not a worry because lit and web components, they were actually made with TypeScript and they work great with JavaScript or TypeScript alike. And of course, Web Dev Server, it just works with a transpiled output. So it really doesn't care what you use. It's just going to use the JavaScript. Now, the TypeScript feature I'm really looking forward to using today, and I say that loosely because it's really not a TypeScript feature, but it's why I'm using TypeScript. This is the ability to use decorators. Now, decorators, they can give us some pretty nice shorthand for defining a component in lit, declaring a lit reactive property, and even query selecting within lit an element inside the component. Yes, we could just transpile with Babel to get decorators or even wait a few years until they hopefully arrive in JavaScript, but I feel like using TypeScript is definitely the most popular way to go right now. And I think by injecting TypeScript into our workflow, there's one or two problems along the way we can explore and really get to know our setup with TypeScript. So we'll be using a very minimal TypeScript setup. So the rules we enforce, there's not going to be so many rules at all. They're going to be fairly lax. We just want to see how we're impacted by adding TypeScript to our project and, of course, using those decorators. Also with lit, we're going to end up rendering shader doodle in a bit of a non-standard way. Okay, that's an understatement. It's a very non-standard way. As we'll hear from Merle, shader doodle, it doesn't yet support the ability to swap out our shaders yet. You might remember that lit is pretty performant, and part of that is only re-rendering what changes. We're not tearing down components, and we're not like yanking them out of the DOM. So when we swap in new shaders, shader doodle, it can't quite keep up. It needs to be reinstantiated to use that new shader as we swap it. So we're going to do things in a very non-lit way and carve out a tiny little piece of our application where we can add and remove shader doodle programmatically. We're going to be yanking it out of the DOM when we're done with it and swapping that shader and adding it right back into the DOM when we want to start it up again with a new shader. I should also note that we won't be exploring application and component organization in this episode. In fact, this app we'll be creating is all one big web component. Yeah, it's going to get a bit long and messy, but I think we have enough to explore today. And we just walked through that in the last episode, so I think we can leave that aspect alone for today. Moving on to our last tool, Web Dev Server. There's not going to be a huge change here, but we will be consuming a troublesome library for creating GIFs that it's honestly aged, and it's not compatible with modern ES modules. So we need some help with that. We need some plugin help with that, and we're going to be adding plugins by way of a new Web Dev Server config. We'll also be using another plugin to help us pretend that we aren't doing CSS and JavaScript. We're going to pretend it's all CSS. We're going to pretend we can actually import CSS as a module into our component. So we'll be working with CSS files directly. Now, even though CSS modules did just land in Chrome, they aren't yet shipped in Safari or Firefox. And in fact, it remains to be seen if this feature will ever be shipped in those browsers. I hope it does, but in the meantime, we can employ a bit of a server hack and let us pretend that we're in the future, right? Now, you might all be worried about all this plugin use. After all, Web Dev Server, I love using it. I think you do too, but it's a semi-new tool. How could this plugin ecosystem that Web Dev Server gives us have everything we need compared to a solution like Webpack that's been around for ages? Can we do everything we need? And now I'm sure by me asking you this question, you can kind of guess the answer is going to be yes. I really have found we have everything we need with Web Dev Server. Now, this is due to Web Dev Server's plugin system. It's all based on Rollup. This means that there are tons of Rollup plugins that we can use, and we just adapt to Web Dev Server by way of a tiny little wrapper. Not every Rollup plugin will work. Some, they just don't make sense. For example, so Rollup is a bundler by its very nature. You're creating builds with it. Part of the plugins you can use for it are asset copying and cleaning your build directory. But it's hard to imagine those being needed for just dev serving when you're coding your application. So those probably won't work well in web dev server, but anything else that makes sense in this scenario, I found it does work. And being rollup based has some very exciting implications beyond just having some nice options for plugins. It means that our entire web dev server setup can be replicated for our build tooling, plugin configurations and all. We'll explore this by creating a rollup-based build that mirrors our web dev server config to a T. But of course, before all of this, we're going to be exploring what Shader Doodle is and asking its creator, Merle, all about it. Now, a bit of a sneak preview. Unlike the halftone renderer in our first episode, Shader Doodle, it's already a web component. In the first episode, we fed the code for Dimitri's halftone experiment into our mysterious AI and space radiation-powered web componentron, and it gave us the web component that we use for the application. But this time around, we have an amazing WebGL shader creator and renderer that was made as a web component from the get-go. So I am really sorry, buddy, but we're actually not going to be needing you this time around. Next episode, I promise you, you're going to be doing amazing things for us. Anyway, I am really excited about both our halftone application and our new Shader Doodle application. Talking with both Dimitri in the last episode and Merle upcoming in this one, it's all been super interesting. I'm really starting to think that my reason for being in space, those forces that made web components so powerful when SpaceX returned back to Earth with web components at its helm, and they spread all over the planet, those forces are at play here as well. Now, I was reviewing footage from the very first episode, and I can definitely see some video artifacting and a mysterious green glow all around me. Now, we're trying to tweak this for this episode, but it can really only be attributed to some sort of mysterious space radiation. So fingers crossed, we're on the right track with our web components experiments. I'm excited to go full steam ahead, explore Shader Doodle, talk with its creator Merle, and then build an application. So stay tuned for the next segment, our show and tell, where we explore what Shader Doodle is, how you can use it, why you might need it, and then of course we're going to talk to Merle, so stay tuned.